Okay, so let's look at 7-2. We don't have a ton of notes today. Going to be pretty similar to what we did yesterday, except we're going to talk about division. Okay, 7-2, division properties. Same big idea as we did yesterday, except we're looking at division. So let's think about this. Let's use common sense. Quotient property of powers. Quotient means what? Divide. So we are dividing, power means exponent. So we are dividing exponents. So if I look at this, let's think about this. If I have something like, I don't know, x to the 8th over x to the 5th. Let's use common sense. When I was multiplying, what did I do with my exponents? Add them. So if I'm dividing, I will probably do what with my exponents? Subtract them. Okay? So it's the exact opposite of multiplying we added, dividing we subtract. So I'm going to write it out. When dividing exponents with same base, they have to have the same base again. You usually won't have to worry too much about it, but make sure they have the same variable with the exponent. So when dividing exponents with the same base, you subtract the exponents. The exact opposite of what we did yesterday. When I multiplied, I added them. When I divide, I subtract the exponents. That's the only difference for right now. So it's important to look at it and say, am I dividing these two? Am I adding these two? Am I subtracting? Am I multiplying these two monomials? It's important to kind of look at them and see what you're doing, because that tells you what to do with your exponents. So if I look at for the first couple examples, I want to see what am I doing with these two monomials. So example 1, I have a monomial on top and a monomial on bottom. So these two monomials, I am doing what with them? I'm not talking about exponents yet. I want to talk monomial. So what am I doing with this monomial up here and this monomial? I'm doing what with them? Dividing. Okay, I see the fraction bar. So I am dividing those two monomials. So if I'm dividing those two monomials, what do I do with my exponents? Subtract them. That's it. So if I look at my variables, they have to have the same base. So let's look at my x's. I am dividing the monomial, so I subtract the exponents. So what is 3 minus 2? 1. So x to the first. You don't really need to put the 1 there, but I'll just put it for now. If I look at my y's, this is going to be y to the 4 minus 1 third. So x, y to the third. And I want to simplify. So the 3 rules for simplification. Single whole number or reduced fraction, which we don't have one, so we don't need to worry about it. No repeating variables, we're good. No negative exponents, we're good. So that's my answer. Okay, so when I'm dividing two monomials, you subtract your exponents. Okay, let's go ahead and look at B real quick. Do B real quick on your own. I'm dividing these two, so you subtract your exponents. These take about 30 seconds. We'll get to trickier ones, but these ones right here take about 30 seconds. Okay, that's going to give me k to the what? Second. 7 minus 5. K to the second. Subtract your exponents. M to the 7th. 10 minus 3. Subtracting my exponents. Now if I look at the p's, there's a couple ways we can think about it. If I do 1 minus 1, what's 1 minus 1? 0. And p to the 0, anything to the 0 is just 2 to the 0 or 3 to the 0. Anything to the 0 is? It's 1, which we'll talk about in a second. So this will technically be 1, which we don't really need to worry about because I'm multiplying by 1. So anything to the 0 power is 1. So you just basically cancel them. Okay, so anytime I'm dividing and I have the same thing on top and bottom, you basically can just cancel them out. It cancels out to 1. So you don't really have to worry about putting 0. You can just cancel them out, but just to show you. So that is my simplified answer. So if it's pretty straightforward, if I'm just dividing two monomials, there's not really a ton of work. You just subtract the exponents. Now they're going to get tricky, but that's the basic idea. Okay, power of a quotient. So let's think about what this means. It means I'm taking a quotient to some exponent, the power of a quotient. Okay, all you do, we did it yesterday, all you do is take top to the exponent and take the bottom to the exponent. So you're going to split it up. So you're going to take the top to the exponent and take the bottom to the exponent. Kind of like we did yesterday, we had a fraction to some power. I took 1 squared and 2, or I think it was cubed, 1 cubed over 2 cubed and got 1/8. It's the same idea. If I'm taking a quotient to a power, you take the top to the power and take the bottom to the power. So if I look at example 2 real quick, let's look at a couple of these. I notice I have a quotient to a power, so I'm going to rewrite it and take the top to the power and take the bottom to the power. That's it. So if I have a quotient and that whole thing is raised to a power, you take the top to the power and the bottom to the power, and then simplify from there. So split it up, put the exponent on top and the exponent on bottom. Now as I look at simplifying this is similar to what we did yesterday. If I simplify the top, how will I simplify the top? Okay, we'll multiply the exponents, but my whole number I treat like normal. So what is 3 to the 3rd power?
9 or 6.
Nope.
3.
Nope. Grab a calculator if you don't have one. So make sure you can do exponents on your calculator because you're going to have to do it for the homework. It's 27, but grab a calculator just to make sure you can do exponents on your own. So make sure you know how to plug in 3 to the 3rd. 3, caret button, 3. Make sure you know how to do them.
3 to the 3rd is 27. So it's going to be 27. Now when I have an exponent to another exponent, what do I do with them? So that's going to be x to the 12.
So the top is simplified. The bottom, how do I simplify the bottom? Okay, I could, or use the caret button. Stop doing the multiplication thing because you get big. That's fine. 4 caret button 3. 64. Okay. Does it look simplified? Why is it not simplified? Okay. If you remember from yesterday, the 3 rules we talked about to tell whether something is simplified. It has to be down to a single whole number or a reduced fraction. So I want to look at this fraction, 27 over 64, and I want to see if I can reduce it. We've reduced fractions since middle school. So I want to look what is the biggest number that I can divide 27 and 64 by. So what numbers multiply into 27? Give me some numbers that multiply into 27 or that are factors of 27. 3. Can I take 64 divided by 3? Try it on your calculator. So I want you all working through this process because you're going to have to simplify fractions. Can I take 64 divided by 3?
No.
No. So 3 doesn't work. What else can I divide 27 by? 9. Can I take 64 divided by 9? No. Now always check, can I take 64 and divide it by 27? So try 64 divided by 27. Does it come out even? No. So can I simplify 27 over 64? Nope. So leave it as 27 over 64. So always check and make sure your fraction is simplified. So either a single whole number or a reduced fraction. That's what we're looking for. Okay. Go ahead and try B on your own real quick. So try B on your own. Same sort of idea. I have a quotient to a power, so take the top squared, bottom squared, reduce each one. So just work on B. We'll work on C in a second, but just work on B. Okay, so let's look at this. Hunter, what's the first thing you did?
Parentheses, the top one.
Okay. And then what did you do?
Put a 2 out.
Okay. And then the bottom looked like what?
6 with those.
Yep. 6 squared. Yep. So the first thing you want to do when I have a fraction to an exponent, take the top to the exponent, take the bottom to the exponent, and then simplify from there. So Caleb, how did you simplify the top? Okay, and did what? 5? Okay, 5 squared, or 5 times 5, which is what? 25. So your whole number you treat like normal, just do 5 squared. And what do I do with my exponents when I raise them to another power? So that's going to be x to the y to the second over 36, 6 squared, 36. So now I want to make sure, 3 rules of simplification. Whole number or reduced fraction. I don't have any repeating variables or negatives, so we're good. 25 over 36. Can I reduce 25 over 36? No. Okay? Think, what are some things that go into 25? 5. 5 doesn't go into 36. I can't take 36 divided by 25, so that doesn't reduce any. So that is my simplified answer. Okay, any questions so far? Okay, let's look at C. I just want to look at as many examples so you have lots to look at when you start the homework. The homework will look similar. First thing I want to look at for C is I want to take the top and the bottom and raise them both to the third power. So like I did, I want to take the top to the third power, the bottom to the third power, and then let's work at simplifying these. So my top will simplify to what? Someone who hasn't answered one. Sean, what will my top simplify to?
64.
Yep, 64. 4 cubed. So 4 cubed is 64. Multiply your exponents, x to the 9th. Good. The bottom will simplify to what? Madison, what will the bottom simplify to? So do your whole number, 5 cubed. What's 5 cubed? 125. And that's going to be y to the 12th. Multiply your exponents. Good. And then 64 over 125 doesn't reduce. So that's my answer. Okay. Questions so far? Kind of similar to yesterday. Missed this division? Okay, zero exponent property. This is the easiest property you will ever do. We already talked about it. Anything to a power of 0 so anything underlined, italicized, bold, 50 font, whatever, anything to a power of 0 is what? 1. Anything. So anything to a power of 0 is always 1. So if I look at example 3, I want to simplify each expression just like I did. So something you need to be on the lookout for is look at, if I have an exponent of a 0, I know that part is just 1. So as I look at this, where do I have an exponent of 0? D. So this is just going to turn to 1. Not an exponent of 1. Let me do that whole number 1. And I'm multiplying by 1. So do I really need to put the 1 there? No. So it's just going to be b to the 4th, c to the 2nd, over b squared c. Is this simplified? No, why not? It has 2 b's, it has 2 c's, so it's not simplified yet. So how do I simplify this using what I just talked about? I'm dividing, so I subtract the exponents. So it's going to be b to the 4 minus 2, c to the 1st. So I'm not going to put the 1 there. That's it. If I look at b, this whole part, this whole mess in here is raised to the 0 power. So what's my answer? 1. Anything to a 0 power is always 1. Even if there's a lot of crap in the parentheses, that whole thing is in parentheses, so that whole thing is raised to the 0 power. So it's just 1. Okay? Last one we're going to talk about today, negative exponent property. This is how I deal with negative exponent. That's the third part of simplification. The first one is single whole number, reduced fractions. Second one is no repeating variables. The third one is no negative exponent. We haven't dealt with those yet. This is how you get rid of negative exponents. If let's say I have x to the negative 2nd. I'm just going to write this out for you instead of writing it out in words because I think that's confusing. If I just have x to the negative 2nd, I can write that as over what? I can write anything over what to make it a fraction? 1. So if I rewrite that as over 1, this is how you get rid of negative exponents. You switch the position. So if this is in the top, you're going to switch the position. You're going to put it on the bottom. So you're going to switch the position. You're going to put it over on the bottom. So it's going to be 1 over, and you're going to make the exponent positive. So switching where it is from the top to the bottom makes that a positive exponent. That's all you have to do. Don't overthink this. So if I see I have a negative exponent, I move it to the bottom or the top and make it a positive. So if I started with something like this, x to the negative 5th. If I start with that negative in the bottom, where do I move it to? The top. And I make it a positive. So over 1 or just x to the 5th. So the way I deal, if I have a negative exponent, I either move it to the bottom if it's on the top, or I move it to the top if it's on the bottom, and I make the exponent positive. That's it. That's all you do. Okay. Any questions so far? Okay, a couple more examples. We can do this. Okay, let's look at example 4. Simplify each expression. Assume that no denominator equals 0. Don't really worry too much about that part. I want to simplify. 3 rules of simplification that we talked about yesterday. Okay? So, first thing I want to look at is I notice, what am I doing between these two monomials? I'm doing what? Dividing. So I do what with the exponents? Subtract. Okay, so let's look at my exponent. Let's start with the v. I just start with the first exponent I see. V to the negative third. Is there any other v's in the bottom to combine it with? No, so I'm going to keep it as v to the negative third. There's no other v's to combine it with. I'm going to keep that as v to the negative third. Now let's look at the w's. If I look at the w's, what do you notice is going to happen? I have a w to the first on top and a w to the first on bottom. So what's going to happen to those? I will, but we can do a shortcut. If I have the exact same thing on top and the exact same thing on bottom, what can I do with them? Cancel out. So my w's are gone. If I have the exact same thing on top, exact same thing on bottom, they cancel out to 1. So you can just cross them out. X to the, do I have any other x's to combine it with? Nope, so I can leave it x to the second. And then if I look on the bottom, y to the negative 6, do I have any other y's to combine it with? No. Now, this kind of looks simplified. There's no repeating variables. I don't have any whole numbers to deal with. But the third thing, I have negative exponents. So how do I deal with those negative exponents? Flip them. So if I have x squared is positive, so I can leave it up there. V to the negative third. If I have v to the negative third, where do I put that to make it a positive exponent? On the bottom. So I put v to the third on the bottom. That's it. So if it's a negative exponent, you switch this position. So if it's on top, you move it to the bottom, make it positive. Y to the negative 6, where will I move y to the negative 6 to make it positive? Top. So that just is y to the 6. That's your answer. No, doesn't matter the order, because we're multiplying, so the order doesn't matter. Good question. Usually they go in alphabetical, but I'm not going to count off. I don't really care. Okay, any questions so far? Okay, let's look at example P. There's lots of stuff going on. I get these look confusing. Okay, all you're going to do is you notice I am dividing, so we're going to subtract the exponents. Now look at my whole numbers here. So if I look at the whole numbers, 32 and 4, what do I do with those whole numbers? Divide them. The whole numbers you treat like normal. So if I'm dividing, you divide your whole numbers. So what is 32 divided by 4? 8. So we're going to put an 8. And technically we're going to put it all over 1. Since 8's on the top, we're just going to keep track of the top and bottom. So 8's on the top because it's a whole number, so we're just going to put an 8 there. Now, as I notice, I am dividing, so I subtract my exponents. Please be careful with this when we're subtracting. As I'm looking at my A, we always start up at the top. So when I'm dividing, when I'm subtracting my exponents, you always start them out at the top. Just get in the habit of doing that. Look at my exponents on my A. What is negative 8 minus 3? Negative what? 11. If you cannot subtract in your head, use your calculator. Do not make silly mistakes. We are subtracting. Negative 8 minus 3 is negative 11. So I put a to the negative 11th on top. Let's look at my B. I subtract my exponents. So what is 3 minus 5? Negative 2. If you struggle with positive and negatives, use your calculator. If I look at my C's, you always start them up at the top. Negative 4 minus a negative 5. If you need to write it out, write it out. Negative 4 minus negative 5. 1. Positive, positive. Negative 4 plus 5 is 1. So that is just C to the first or C. So be careful with your negatives. Use a calculator if you need to. Now, is this simplified? It's basically simplified. What's the only thing I need to do to simplify? The 1 is fine. Yeah, I mean it's 8 over 1, which the 1's fine. The negative is what I need to worry about. So what do I do to make this 8 to the negative 11th not be negative? Push it to the bottom. That makes the exponent positive. How about b to the negative 2nd? Put it to the bottom, make it positive. And do I have to do anything with my C? No, it stays on top. So that's my answer. So I get it's tricky and it's hard to kind of know where to put things. But if you have a negative, you just switch the spot and make it a positive. That's all you do. Okay, we have one more to look at. And we'll be good. Okay, let's look at C real quick. Any questions so far? Okay, let's look at C. I'm looking to simplify this. Let's start with the whole numbers. I'm dividing. So how do I simplify 5 over 25? Can I divide 5 over 25? No, so I want a whole number or a reduced fraction. So how can I reduce 5 over 25? You know this. If I give you the fraction 5 over 25, what does that reduce to? Divide top and bottom by 5, so that's going to be 1/5. So 1 over 5. So if you can't actually divide them out and get a whole number like the last one we did, just reduce the fraction. 5 over 25 is the same as 1/5. You don't really need the 1 on top, but I'll just put it up there so we have something on top. Now let's look at my exponents. I'm dividing, so I subtract my exponents. I just start up at the top and I just work my way across. If I look at J, is there any other J on the bottom to subtract from it? No, so I just leave it as J to the -5th. I'll deal with the negative in a second. If I don't have anything to subtract it from, I just keep it there. Always start them up at the top. I work my way across. I see a K, so I put a K. I notice there's a K on the bottom, so I do what with my exponents? Subtract. 2 minus, write it out if it's confusing, 2 minus -4. Don't get confused with the negatives. Minus negative becomes what? Positive, so that is +6. Write it out to the side if you need to. Keep track of the negative. Now let's look at my M's. Always start them up at the top. -6 minus -2. So plus, what's the -6 plus 2? -4. So M to the -4th. Okay, one last thing I need to do to simplify this. Yep, move the negatives to the bottom. So on top, what's going to be my only thing left on top? Yeah, I don't really need the 1 there, so K to the 6th. On the bottom will be a 5, J to the 5th, M to the 4th. So move the negative exponents to the bottom, make it positive, and that's it. Okay, any questions? How are we feeling about this stuff? Okay, it's kind of similar to yesterday. So if you did well with yesterday, you should do okay with this. Homework is going to be, it's on the backboard, page 403. (19 through 42). So that's the homework. Okay. There are odds. These are easy to check in the back of the book. So check the odds in the back of the book. See if you're doing them right. 19 through 42. So if I were you, I would get yesterday's assignment done first.